Hello, so I'm going to go through the answers to these momentum questions. So it says the figure below shows an ice skater standing on ice. Write down an equation that links acceleration, change in velocity and time. So the equation is acceleration equals change in velocity divided by time. And you can have any rearrangement of that would be correct. And it says, as the skater pushes away across the ice, there is a small frictional force. After pushing, the skater starts to move with a velocity of 5 meters per second. So his initial velocity, u, is 5 meters per second. Slows down to 3 meters per second, so the final velocity is 3 meters per second. And it says that that takes a time of 6 seconds. And it says calculate the acceleration. The acceleration is the change in velocity, so that's v minus u, so what you end up at, take away what you started at, divided by time. So we're going to do 3 take away 5 over 6, which gives us minus 2 over 6, okay, which gives us an answer of minus 0.33 meters per second squared. Then it says, write down the equation that links acceleration, force and mass. So force equals mass times acceleration is the equation. And then it says, friction force reduces the speed of the skater. Calculate the frictional force. So we're going to use F equals ma, which is what we just wrote down, and we know that the acceleration is minus 0.33. And in the question, right at the start of the question, it tells us his mass, and the mass of the skater is 70 kilograms. So that's 70. Okay? So if we're going to do 70 times minus 0.33, which gives an answer of minus 23.1 newtons. It doesn't matter if you don't get a minus, that's okay. Okay. Then it says the skater stands still on ice. He throws his bag to a friend. As he throws the bag forward, the skater moves backwards across the ice. Use the idea of conservation of momentum to explain why he moves backwards. Whenever a question says use the idea of conservation of momentum, you should say what the conservation of momentum is. So conservation of momentum means that the momentum before equals the momentum after. Okay? So, when before the momentum is 0, because the skater and bag are stationary. Okay? After, he gives the bag forward momentum, so he moves backwards, so that the overall momentum is 0. Because basically, if the bag has forward momentum, he has backwards momentum to cancel that out. So he moves backwards with the same momentum as the bag. So overall, there is 0 momentum, which is what we're saying there was before. So momentum before equals momentum after. Before, the momentum is 0 because the skater and the bag are stationary. After, the bag has forward momentum, so he moves backwards with the same momentum, so that overall there is 0 momentum. Right, question 2. The diagram shows an air-driven toy. When an electric motor is switched on, the fan rotates. The fan pushes air backwards, making the toy move forwards. The toy has a mass of 0.15 kilograms and moves forward with a velocity of 0.08 meters per second. How is the momentum of the car calculated? So momentum P is mass times velocity, which is the third one. What is the unit of momentum? It's that strange unit, kilogram meters per second. Use the correct answer from the block to complete the sentence. The momentum of the air backwards is equal to the momentum of the toy forwards. That's because of Newton's third law, equal and opposite. Then it says the electric motor can rotate the fan at 2 different speeds. Explain why the toy moves faster when the fan rotates at the higher of the 2 speeds. So the answer it's looking for here is that when it's on a higher speed, okay, the air has more momentum. Backwards. Usually when you're talking about momentum, you need to talk about the direction. So yeah, it has more momentum backwards, okay, because it's faster. So that means that there must then be more momentum forwards to cancel that out. So the momentum of the toy forwards also increases to balance the backwards momentum. It's always hard talking about momentum, but you're always trying to look for a balance between the two. Question 3. Diagram shows a skater. Write down the equation that links mass, momentum and velocity. So momentum equals mass times velocity. And a skater travels with a velocity of 3.2 meters per second and has a momentum of 200 kilogram meters per second. Calculate the mass of the skater. So we're going to substitute into our equation. Momentum is 200. Mass we don't know, so we'll just call it m, and the velocity is 3.2. Divide both sides by 3.2, and that will give us our mass because those cancel. So 200 divided by 3.2, which gives 62.5 kilograms as our answer, or 63. 2 significant figures. It then says skater A bumps into another skater, skater B. So skater A is travelling along, bumps into skater B who was stationary. And the skaters, so that's before and after, the skaters move off together, which is very nice, and they'll move off with the speed that we don't know. Explain what happens to the velocity of each skater. So, okay, as A bumps into B, their momentum will decrease, so their velocity will decrease. So their momentum decreases, so the velocity decreases. B's momentum will increase because they didn't have any, and then they start moving. So for B, the momentum increases, so the velocity will increase too. Okay? Number 4, a paintball gun is used to fire a small bullet of paint called a paintball at a target. The figure below shows someone about to fire a paintball gun. The paintball is inside the gun. What is the momentum of the paintball before the gun is fired? So it is 0 because it is not moving. Okay, so there is no velocity. There's no velocity. The gun fires the paintball forward with the velocity of 90 meters per second. And the paintball has a mass of 0.003 kilograms. Calculate the momentum of the paintball just after it's fired. So momentum is mass times velocity, so 0.003 times 90, which gives us an answer of 0.27. Then it says use the momentum of the gun and the paintball is conserved. Use the correct answer from the box to complete the sentence. The total momentum of the gun and paintball just after the gun is fired will be equal to the total momentum of the gun and the paintball before the gun is fired. Okay? Lovely. Give yourself a mark out of 5, 15, 27. So out of 27. So for 80% fluency, which is what we're looking for, you need 22 marks. So it'd be great if you could get 22 marks out of 27. If not, have another go at them in a few, and see how you get on doing them again. Okay.